Okay, so this video is about adding, subtracting, and multiplying polynomials. So the first thing you may already know, but I want to make sure we're all clear on, is in order to add or subtract polynomials, you have to combine like terms. It's only for adding and subtracting. It doesn't apply to multiplying and dividing them. All right, but in order to add or subtract them, we have to combine like terms. So what I mean is this. Okay, so this is a polynomial. This is polynomial 9x cubed, subtract 2x plus 1. Plus, this is the second polynomial. This is polynomial 5x squared plus 12x, subtract 4. This is a polynomial because it's a collection of multiple terms. All right, what makes this a term? This is a term. This is a term. And this is another term. Those are all separate terms. Why? They're separated by addition or subtraction symbols. Had they been connected with multiplication symbols, for example, 9 times x to the third, there's no symbol there, so it implies there's multiplication happening. So had it been connected with multiplication, they're not separate terms. They're combined to be one term. So this is one term, the 9 and the x to the third. And then the 2x is one term alone, and I'll use a negative sign in front as well. And the 1 on the end is one term. All right, so it's a polynomial, poly, being many. Basically, poly is a word for many, and polynomial. So each one of these are monomials. So it's many monomials. All right, so these are two polynomials you want to add, and in order to add them, you have to combine like terms. So let's actually add them. All right, in order to add them, we have to get these parentheses off. Only way we can get the parentheses off is to multiply by whatever in front of the parentheses. Here, there's understood 1 in front of this parentheses. So technically, if I distribute 1 to all of these, it doesn't change any signs. 1 times each of those, because that's a positive 1, none of the signs change. So technically, I can just drop the parentheses off without having distributed 1 into it. So it's 9x to the third, subtract 2x, plus 1. Plus, here we also have parentheses. Here we also have a plus, as understood 1 here. So I distribute 1 here. Again, it doesn't change anybody's signs, so I can drop them down without having any signs change. From there, you want to find the terms that have the same exponent. These exponents are called its degree. So this has degree 3. This has degree 1, because I understood 1 there. This has degree 2. This has degree 1. This didn't have a variable, so it has degree 0. So anyway, you look for all the ones with the same exponent or same degree. So 9x cubed. It doesn't match with anyone. So when I combine these, my first number is going to be 9x cubed. The next number is squared. So I got 5x squared. There are no other x squareds here, so there's nothing to combine with. So the 5x squared continues just as it is, unchanged. Then I have a 2, well, I will use a different line. That has 2 lines, this has 1 line. All right, I have a negative 2x to the first and a positive 12x. These are like terms. They both have the same variable x to the first power. So in order to add them, you simply combine the coefficients just as they are. So this being negative 2 plus 12. So you don't change the sign, as in add 2x here and add 2x there. You wouldn't do that because you're on the same side of the equal sign. So this would be wrong to change the sign to add it to the 12. Even though it's far away, you don't change the sign because it's on the same side of the equal sign, so you really combine them like you are. So you wouldn't do that. That would be wrong. But you would add them just as they are. So negative 2x plus 12x should be a positive 10x to the first. And then the last one is the ones. I'm going to use a box around the numbers without variables. You use whatever symbols you want to organize them. But the 1 and the negative 4 combine to be a negative 3. So positive 1 and negative 4 is a negative 3. And then after I get done, I'll take a look at that to see if I missed anything, see if I still have any like terms left. So I got 9x to the third, 5x squared, x to the first, and negative 3. Then nobody's over here no term over here has the same degree as anything else. So there's nothing else I can add. So this would be the final answer for it. So this polynomial plus the other one combines to be this new polynomial. All right, new example. All right, let's just subtract the polynomial. All right, so I'm going to subtract this like I did last time. If you think you understand this, you don't have to wait for me. Pause the video and try this one on your own. So if you think you understand what to do, go ahead, pause the video and try this one without my help. So go ahead, pause it now. All right, so if you're done pausing it and you're looking at it again, I will look at this and I'll consider the number in front of the parentheses so I can drop the parentheses off. So understood 1 here. So understood 1 there. So when I distribute 1 into the parentheses, 1 times 2x squared is 2x squared. 1 times 3x is 3x. And then here is a negative 1 here. So I got to distribute negative 1 to every sign in there. This makes it different because now this negative 1 changes every sign within the parentheses. So negative 1 times 3x squared is a negative 3x squared. And then negative 1 times a positive x is a negative x. And negative 1 times a negative 4 is a positive 4. All right, so now I'm going to look for my like terms. And I'm going to look for, this is my quadratic term. This is another quadratic term. Why is it quadratic? It's to the power of 2, or has degree 2. So these are like terms. And this is a linear term because it's to the degree 1. So if you graph that little piece of it, it's a line. So this is my linear term. I'll give it a circle. This is the other linear term. And then this is the constant, and it doesn't have anything to match with it, so it's by itself. So when I combine my like terms, I should wind up having 2x squared subtract 3x squared gives you negative 1x squared. And then I'll use those. And then 3x and then negative x. 3x is subtract 1x leaves you with 2x. So it's positive 2x left. So I've used those. And the last number on the end is 4. So this polynomial, subtract the other, leaves you with negative x squared plus 2x plus 4. All right, new example. All right, this new example deals with multiplying polynomials. And we're multiplying them, for example, I multiplied x times 5x to the 5th power. The understood numbers in front here is understood 1 in front of the x. So it's really 1x times 5x to the 5th power. So I can really group together the coefficients, 1 times 5, and I can group together the variables, x times x to the 5th. And just know that when you're multiplying these numbers, it's 1 times 5, so just 5. And when I'm multiplying variables, I add the exponents. So this exponent is 1, so x to the 1st times x to the 5th is x to the 6th power. All right, so just understand that as we try to multiply these. Back to the problem at hand. All right, this says multiply this binomial times this trinomial. And there's lots of ways of doing it. I'll suggest you multiply each term from the binomial into the larger trinomial one at a time. So I suggest you take the x and distribute it 3 to each one using distributive property multiplication. So it's x times 3x squared, which is 3x to the 3rd. Then x times a negative 2x is negative 2x squared. And then x times negative 4 is negative 4x. Then usually organize in a way that your next line could be written beneath. So negative 3 times each term. So negative 3 times a positive 3x squared is a negative 9x squared. And notice how it lines up with one of the numbers already. And then negative 3 times negative 2x is a positive 6x. And that lines up with one that's already there. And then negative 3 times a negative 4 is a positive 12. All right, from there, you just add. So that way I don't have to worry about changing any signs, whatever. I'm just adding these together. So 3x cubed plus nothing is 3x cubed. And then negative 2x squared plus a negative 9x squared is a negative 11x squared. And then negative 4x plus a positive 6x is a positive 2x, and plus 12 is on the end, with nothing to add to it. So I'll make sure I don't have anything that I can add, so make sure I'm finished, and that looks finished. So that's the final answer for the product of both of those. The other ways of doing it too, I just think that works best. All right, another example. All right, multiplying 3 binomials. So if you multiply 3 binomials, you can only multiply 2 of them at a time. So either you can choose the first two to multiply, the last two to multiply, or the first and last to multiply. I like to use the last two just to get that out of the way and then distribute the first one into it. So if I was multiplying these two together, I would take, or let's just use the first two, that doesn't matter. So I'm going to take x times the first, and x times the 4. And I only distribute it to the first binomial. I wouldn't bother distributing it there. So it's going to be x squared plus 4x, then negative 1 times each one. So that makes it negative 1x, subtract 4. All right, those two combine to be x squared plus 3x, subtract 4. All right, and then this is going to be multiplied to this one, so we'll put it in parentheses. And either you can take this long one and distribute each one into the shorter one. I find that very confusing. So I'll generally take the short one and put it in front. So it's the short one into the long one. So I'll generally rewrite it. So I'll call it x plus 3, and then x squared plus 3x, subtract 4. And then distribute that into each term. So x goes in each one 3 times. So x times x squared is x to the third. X times 3x is positive 3x squared. X times negative 4 is negative 4x. And then 3 to each one. So 3 times x squared is 3x squared. 3 times 3x is positive 9x. 3 times negative 4 is negative 12. Combining your like terms, you wind up having x to the third plus 6x squared plus 5x, subtract 12. And this is it. There's nothing in there that can be combined any further. So that's the answer for it. All right, one last example. If you didn't get that already on your own, I'll copy that as a note. I got one last example, that's it. All right, so the rules for squaring a binomial. This is a binomial. We're squaring it, and you can always take it and call it a plus b times a plus b and multiply those together. However, the rule is, saves a little bit of time, is square the first, multiply and double, square the last. And that goes even in subtraction. So the rule is this. Square the first term, multiply them and double, so a times b, then double it, so 2 times ab. Square the last. So whatever the last term is, you square it, so it's b squared. And work the same with subtraction. And so the middle term, we multiply those together, the middle term gets a subtraction symbol, I'll be double it. So that's the rule for it. So let's actually do a couple. This is what I mean. So take both of these, x plus 5 and square it, then take 2x subtract 9 and square it. And see if you can figure it out without my help first. Then check mine to see if you got it right. So pause the video. All right, so you gave it a shot. The rule says square the first, multiply and double, square the last. So if I square the first term, it's x squared. If I multiply those together, it's 5 times x, so it's 5x. Double it, it's 10x. Square the last. Whatever that number is, you square it. So 5 squared is 25. So that's what that would be. And the one beneath, again, square the first. So when you square this whole term, you square the 2 as well. So it's 4x squared. Multiply these together. So it's 2x times 9 is negative 18x. And double it, it's negative 36x. And then square the last, plus 81. So you could have got that by foiling it, but that does save you a little work. So that's the rule for squaring a binomial. That's all I have. Good luck.